fractions. Now, this is going to be our new topic, but common fractions is not a completely new topic we have ever learned about it before. Now, the section that we would like to discuss today is decimal fractions and common fractions combined. It's like we are going to be looking at how to get from common fractions to decimal fractions, and then later from decimal fractions to common fractions. But well, why do we need this fraction thing? And what is it anyway? Now, notice in this section of decimal fractions to common fractions or common fractions to decimal fractions, we will want to study, okay? We will learn more about fractions and what these numbers are used for. What are fractions used for? And what does it mean, a fraction? A fraction means a part of, okay? So if you talk of buying something, or for example, paying tuition or school fees, if you have not paid your school fees in full, then you have paid a part of your school fees. Okay, that is, if your parents have not paid a full school fees, then they have paid a part of your school fees. Or we can also say they paid a fraction of your school fees. Okay, if you have been served lunch and you did not eat it all, that means you ate part of the lunch or part of the meal. And so we can say you ate a fraction of the meal, okay? So we use, you know, if we use only whole numbers, like 0, 1, 2, 3, 4, 5, 6, like that, in trying to describe things, then we cannot always describe, you know, quantities precisely. We cannot describe everything the right way, the precise way. We always have to use fraction if we want to describe things as accurately as possible. Now, fractions were invented so that any quantity can be described accurately. So now we will be moving right away into our section of how do we convert, you know, this element of fractions, you know, from one form, decimal, say, to the other. But before we get to that, we want to see, that is, before we get into fractions in decimal notations, we want to see how we generate these fractions. How do we even write these fractions, okay? Now, that means we are going to use this table, which I have drawn here, having, you know, these boxes or these squares, some being colored, others are not colored. And so we will start right away with this quick question, that what fraction of each square, okay, what fraction of each square is what? Is colored. What fraction of each square is colored? So now when you look at this question is going to require us to use this diagram, which I've already drawn, or these squares that I've already drawn. So right away, we are going to call question 1 as 1.1. So before we get to 1.1, we are looking for the fractions that have been colored, okay? The fractions of the squares that have been colored. That is part of these squares that I have drawn right here. You see, for example, you can count in question 1.1.1, rather 1.1. One thing we notice is we have 6 squares. That is 1, 2, 3, 4, 5, 6. Those are 6 squares. And then we count in the second question 1, 2, 3, 4, 5, 6, 7, 8. You know, when we count in the next, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It keeps on increasing like that. And so before we move into how we express fractions as in decimal notations, we want to see how do we generate this fraction? How do we even write them? Okay, So in question 1.1, we are supposed to write a fraction of the squares that have been colored. Now notice that out of the 6 squares, only 1, 2, 3 have been colored. And so in fractional notation, okay, writing it in fraction, we are going to be having out of the total squares, okay? We could say 3, okay? 3 out of what? 3 out of 6. 3 squares out of 6 are colored. Yes. But now in a fractional notation, when we write it in fraction, we want to write it with the one number being a numerator and the other number being a denominator. And so out of 6, how many have been colored? 3 have been colored. So in fractional notation, question 1.1.1 is written as 3 out of 6, or 3 divided by 6. And we call this 3 as the colored squares and the 6 as the total number of squares. So this is how we write it in fractional notation. Now notice that this numerator can be divided by itself, okay? This numerator can be divided, all right? Well, what are we trying to say? We're actually trying to say 3 can be divided by 3. And when we divide 3 by 3, we also need to do the same with the what? With the denominator. What is that supposed to give us? Well, that's supposed to give us, in fractional notation, 3 divided by 3 is what? Is 1. And 6 divided by 3 is what? Is 2. And so instead of writing it as 3 out of 6, we can now write as 1 out of 2. Now that is how we would do this question 1.1, writing this number of squares or the colored number of squares as a fraction of the total number of squares. Remember we said a fraction means a part of. So that means out of 1, rather out of 2, or the way it's indicated here, 1 out of every 4. So that means 3 out of every 6 is colored. Also here, which is now reduced, 1 out of every 2 is colored. Now the next question is what? Well, we count 1, 2. 2 have been colored. So what do we say? 2 out of, okay, out of what? 1, 2, 3, 4, 5, 6, 7, 8. So 2 out of 8 have been colored. All right, so we write 2 out of 8 squares are colored. Yes, this is what we have got. 2 out of 8 squares are colored. So in fractional notation, we say 2 out of 8 have been colored. Now notice that we can do what? We can simplify 2 out of 8. It's always good to simplify before you leave and move to the next question. And so notice that the numerator, which is 2, can be divided by 2, and also the denominator 8 can be divided by 2. And so when we divide the numerator, that is 2, we divide it with 2, and also we divide the denominator 2 by 2. What we get in fractional notation this time will be 1 for the numerator and 4 for the denominator. Okay, so this is the fraction of the squares which have been colored, meaning 1 out of every 4 squares is colored in question 1.2. Then now in the next one, we want to look at what is given to us. Well, now notice that we have 1, 2, 3, 4, 5, 6 squares have been colored. And so we write 6 out of what? 6 out of, well, we count again, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 out of 9 squares are what? Are colored. Yes, 6 out of 9 squares are colored. And so in fractional notation, how do we write that? Well, in fractional notation, this one will then give us 6 out of 9 have been colored. Okay, well then, is there a need to reduce, or is there how we can write this in a much more simpler way? Okay, now when we look at 6, 6 can be divided by 6. This is true. But notice that 9, which is the denominator, cannot be divided by 6. Is there any other number which can divide 6 and also 9? Yes, the number is 3. 3 can divide 6 and also 9. And so what do we have? Well, we then have now to divide the numerator by what? By 3. Why do we do that? Because we want to write the fraction in a much more reduced way. Okay? Well, so what would this be then? For the denominator, we will be having 9 also divided by 3. And so what would we get for that? Well, notice that when we divide 6 by 3, what we get is a 2. And that when we divide 9 by 3, what we get is a 3. So for the third question, 6 out of every 9 squares have been colored. But also we can write it as 2 out of every 3 is colored. This is now the simplified form, okay? And now in the next question, which is question 1.4, what we want to do is to write as a fraction of the colored, what fraction of these squares is colored. So we then count 1, 2, 3, 4, 5. So 5 squares have been colored out of how many? Well, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5 squares out of 15 have been colored. So there we write 5 squares out of 15 are colored. Okay. Yes, this is how we write it. And so now in fractional notation, what we want to write is 5 out of how many? Out of 15 squares have been colored. That means for every 15 squares, 5 are colored. And so is there a way we can write this in a much simpler way? Well, there is a way we can write it in a much simpler way. And what is that? Well, we then have to write this 5 out of 15. We look for a number which can divide 5 and also 15. Now notice that we can divide 5 by 5 and also 15 by 5. And so when we divide 5 by 5 and also when we divide 15 by 5, we get a much more reduced form of 5 out of 15. And what is that reduced form? Well, in fractional notation, we will then be having 1 for 5 divided by 5. Okay, we will be having 1 for 5 divided by 5 and a 3 for 15 divided by 5. Okay, so this is how we write in fractional notation the fraction of squares that have been colored. Now here is the question. What would be the solution for question 4, rather question 5, question 6, question 7, and question 8? Would you like to try that? Well, I'm going to give this for you as what? As a practice question. So I would expect you to do question 5, which in this case is 1.5. Okay, then later you also do question 1.6. Then you also do question 1.7. Then you also try question 1.8, which is appearing here as question 8. Okay, the first step is to count the number of squares that have been colored. Like for question 1.5, you will be having 1, 2, 3, 4, 5, 6, 7, 8, 9. So you say 9 squares out of how many? Well, 10, 11, 12. Out of 12 squares are colored. Now, after getting it in that statement form, you want to write it as what? As a fractional notation. So you will then be having 9 out of 12. And you can go ahead to do what? To reduce it. You would do the same to question 1.6. So the fraction of squares that are colored, you count those that are colored first. What will that be? 1, 2, 3. So you will be having 3 squares colored out of how many? Well, out of 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 3 squares out of 18 are colored. Then after writing it that 3 out of 18 are colored, you want to transfer that into a fractional notation, and that will give you a 3 out of 18. You can go ahead to simplify that. Well, that is how we would write these squares as a fraction of the colored ones. Now, the next question is the exact opposite. Find out what fraction in each square in question 1 is not colored. So the fraction of squares that are not colored, how do we get to that? Well, that is now going to be question 2. So question 2 is about what? It's about squares that are not colored. And how do we handle that? Well, let's get to it right away. So question 2 is about squares not colored. How do we get to that then? Well, let's move to 2.1. So now to 2.1, how many squares are not colored? We count 1, 2, 3. Out of how many? 4, 5, 6. So it will be like 3 out of what? Out of 6 are what? Not colored. 3 out of 6 squares are not colored. Yes. And in fractional notation then, we will be having 3 as a numerator out of 6 as a denominator. And notice that we can still reduce this. So how do we reduce it? Well, to reduce this, we divide the numerator by itself, since we can also divide the denominator by itself. In other words, we divide 3 by itself. Why are we doing that? Because we want to find a simplified form of the answer. And when we divide the numerator by 3, that is 3 by 3, we also divide the denominator, which is 6 by 3. And what do we get for that? Well, 3 divided by 3 is 1, and 6 divided by 3 is 2. Now, that is how you would handle question 2.1. Now, question 2.2 is asking for the fraction of squares that are not colored. Now, we go ahead to count that. 1, 2, 3, 4, 5, 6. So 6 squares are not colored. 6 out of how many? Out of 7, 8. So therefore, we write 6 out of 8 are not colored. Okay? 6 out of 8 are not colored. 6 out of 8 squares are not colored. So in fractional notation, we then be writing 6 out of 8. That is the fraction of squares that are not colored. You could go ahead to reduce it. You look for a number which can divide 6 and also that which can divide 8. Now notice that 2 can divide 6. Okay, so right away, let's see how we can simplify this. So from 6 out of 8, we want to find a simplified expression. That means we need to look for a number which can divide 6 and also 8. And what is that number? Well, you could think of 2, because 3 cannot divide 8. So now we can divide 6 by 2. And also we have to divide 8 by 2. And when we do that, we now have a much more simplified fraction, which in this case is what? Well, when we divide 6 by 2, we get 3. And when we divide 8 by 2, we get a 4. And this is the fraction of squares that are not colored. Now, notice that stopping at this stage without reducing is not a problem. Okay? You can stop at this stage here, 3 divided by 6, or 6 divided by 8. That is equally fine. I'm just extending this so that you have a better understanding of how you can go ahead to simplify your expressions. Now, the next question is asking us to do what? Well, the next question is asking us to find the fraction of squares that are not colored in question 3. Well, the fraction of squares that are not colored requires us, or to get it, we first count the squares that are not colored. In this case, 1, 2, 3. So we say 3 out of 4, 5, 6, 7, 8, 9. Okay, so we say 3 out of 9 are what? Not colored. Because of that, in a fractional notation, we then be having a 3 out of a 9 as a fraction of squares that are not colored. So because we have that, well, as I indicated earlier, we could go ahead and stop here, as this is our final answer. But we could also simplify it. Now, in trying to simplify that, we look for a number which can divide 3 and also 9. And now, interestingly, 3 can divide itself, and 3 can also divide 9. And so then what do we have? Well, we have to divide then 3 by 3. Okay, now when we divide 3 by 3, we will also later divide 9 by 3. What do we get from that then? Well, we will then get a 1 for 3 divided by 3. And then when we divide 9 by 3, what we get is a 3. So this becomes the fraction of the squares that are not colored. Okay, then now for the next question, which is question 2.4, we then be having to count the squares that are what? The squares that are not colored. So we go to 4 and we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we therefore say 10 squares are not colored. But 10 out of how many? Well, 10 out of 11, 12, 13, 14, 15. So therefore we say 10 out of what? Out of 15 are not colored. Squares are not colored. And in fractional notation, we then be having a 10 as the numerator and a 15 as the denominator. This is our answer. We could stop here. But if we are required to simplify this, then we can go ahead and simplify it because it doesn't take much to get this simplified. How do we simplify this then? Well, now to simplify this, that is 10 divided by 15, we want to look for a number which can divide 10 and also 15. If we divide 10 by 10, we soon notice that we cannot divide 15 by 10 if we want to get a whole number. So we look for some other number. In this case, we can take a 5. Now notice that when we divide 10 by 5, we will also have to divide 15 by 5. And now when we divide 10 by 5, what we get is a 2. And also when we divide a 15 by 5, what we get is a 3. And so we then be having a 2 divided by a 3, which means for every 3, 2 will not be colored. Okay, for every 3, 2 is not colored. That is what it means. Okay, now if you look for the next question, which is 2.5 and 2.6, you will have to go through the same step. And for this, I would like to do what? I would like you to try this out as a practice question. And so, to do 2.5, you will have to count the number of squares that are what? That are not colored. So you will be like 1, 2, 3 out of 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 out of 12 squares are not colored. So you write that down as 3 out of 12. And then you write it in a fractional notation, from which you can also go ahead to simplify. Now, when it comes to 2.6, what you want to do is to count the number of squares that are not colored. So we'll be counting as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 squares. Well, 15 squares are not colored. Now, notice it is 15 out of 16, 17, 18. So you say 15 out of 18 are not colored, and then you can write it as a fractional notation. And then you can go ahead to reduce. You would do the same when you reach 2.7. That is, you count the number of squares that are not colored. 1, 2, 3, 4, 5, 6, 7. So 7 squares are not colored. But 7 out of what? 7 out of 1, 2, 3, 4, 5. That is, sorry, 7 out of 8, 9, 10, 11, 12. Well, 7 out of 12. Let's count again. 1, 2, 3, 4, 5, 6, 7 squares out of 8, 9, 10, 11, 12. So we say 7 squares out of 12 squares are not colored. Notice that this cannot be reduced any further. And so you want to write that and move on to question 2.8. And so for question 2.8, you count the number of squares that are not colored. That is 1, 2, 3, 4 out of 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we'll be having 4 squares out of 20 are not colored, and you can write it in a fractional notation as 4 out of 20. And so you can also reduce that down. Now, when we are done with how we can go ahead to generate a fraction, the next thing we now want to do is to find a way of writing a fraction, okay, in a decimal notation, or from a decimal notation to what? To a notation which is known as the common fraction. So how do we do that? Well, that is going to lead us to part 3. So in part 3, what we want to do is we want to find a way of writing a decimal fraction, or a fraction in a decimal notation to a fraction in a common notation, also known as common fraction. Well, how do we get that then? Now, we first have to go through some steps. It's important that we draw a table where the decimal is written. Now, this decimal which have been written, they only show the what? They only show the fractions that we need to find solution for. So we have the decimals here, and we have also a space for the decimal point. Then after that, notice that the number after the decimal point, the first number after the decimal point is called a tenth, or a tenth. A tenth means 1 out of 10 of it. So after the decimal point, the first number is called a tenth. So for 0.2, we have a 2. then a 7 for 0.7, okay? Then for 0.67, 6 is a tenth or a tenth. Then for 0.98, the first number is 9, and so 9 is called a tenth of this expression. Then now for 0.397, the first number after the decimal point, which is 3, is written here, and 3 is called a tenth. That is 1/10 of 3 for this fraction. Then now for 0.587, the first number after the decimal point is a 5. So this 5 is called a tenth. Then now the next number after a tenth is 100. Then for this question, for 0.2, we have 0. There is nothing there. And for 0.7, we have 0. But for 0.67, we have 7. 7 in this case is called 100. Then 8 is called 100. Then 9 is called 100. And then 3. Then now the next number which comes after 100 is called 1,000. And so we have it for this question as 0.397. And so 7 is 100, is 1,000, and also 8 is 1,000. What is that supposed to mean? Well, as I indicated for the first one here, the first number after the decimal point is called a tenth, meaning that number in a fractional notation must be divided by 10. And in the second question, 0.7, 7 is called a tenth, meaning in a fractional notation, 7 must be divided by 10. Now, in 0.67, 6 is called a tenth. That means 6 must be divided by 10. But because we have another number also 7, 7 is under 100, meaning 6 and 7 all together can now be divided by 100. Then now for 0.98, we have two numbers after the what? After the decimal point. And so that means this 98 must now be divided by 100. Now notice that the second number or the last number takes precedent. In fact, it takes what is called preference. It is preferred when we are writing or when we are dividing it by a factor of 10 or by these exponents of 10. So we had said that 8 is under 100. And so, since we want to write all this as 0.98, we will write it as 98 divided by 100. Why? It's because 8 is under 100. So we now divide it by 100. 8 is under 100. Then now for this one, the last number is 7. And 7 is under 1,000. As you can see from here, 7 is under 1,000. And so, in a fractional notation, 0.9397 can be written as 397 divided by 1,000. And so, 0.538 can also be divided by 1,000. This is how we write fractions from decimals to a common fraction. Okay? Once again, we just need to, okay? Once again, we need to get this as clear as possible. Okay? We have to write this as clear and get it as clearly as possible. Okay? So that is what we go through in this case. Now, the next question we now want to look at is going to help us in trying to get us understand what this then means. Okay, so now when you look at the next question here, well, this is question 3. Question 3 is saying, give the decimal form of each of the following numbers. Okay, we are supposed to give the decimal form of each of the following numbers. Okay, now question 3 is actually the reverse of what we have been discussing. Question 4 would have been a much better option for us to start with. That what? We write each of the following numbers as a fraction, okay, in their simplest form. What does this then mean? Well, let's first do question 4 before we do question 3. Why is it so? It's because question 4 is exactly what we have been discussing in our previous question. Rather, question 4 is what was illustrated in our table. Notice in the table, we were talking about moving numbers from decimals to a common fraction. And that is what question 4 is all about. Question 3 is the exact opposite of question 4, which we will do right away. So let's first deal with 4. Then we come to 3. Because 3 is the exact opposite of what we want to deal with. So 3 is very much from, so question 4 is from decimal form to common fraction. So we are going to move this from question 3 to question 4. So then that means we have to move to question 4.1 to start solving. What have we been given to question 4.1? Well, we have been given that we need to convert 0.2 from this decimal to what? To a common fraction. Now, notice that this 2 here is called a tenth. Okay, this 2 is called a tenth. And so, because of that, 2 will then be divided by what? 2 will then be divided by 10. Okay, this is how we write 0.2 in a common fraction way. Then now we can move to the second question, which is 4.2. Now notice that 4.2 is given as 0.87. This is the question. Now, how do we write this as 0.87? How do we write 0.87 in a fractional notation or in common fraction? Now notice that 8 is under a tenth. 7 is under 100. But because we want to write all the 2 as 87, the last number, which is 7, is going to take preference. It's going to be considered in denoting how we divide. 7 is under 100. And so we want to divide this with respect to 7. And so we have to divide it by 100. That is how we convert these fractions from decimal to what? To a common fraction. Now, the next number we want to deal with, or the next question we want to handle, is question 4, part 3. Now, question 4, part 3 is given as 0.07. And so 0.07 in a fractional notation, well, notice that the first number after 0 or after the decimal point is under a tenth. The second number is under 100. And so, since we write in fractional notation, we take the position of the last number, okay? 0 is under 10 and 7 is under 100. So we can write this as 0.7, okay? Divided by what? Divided by 100 or 100. Now notice, instead of writing this as 0.7, we could instead write this as a 7 out of a 100. Yes. Now, the next question, which is question 4.4, is what? Is 12.04. So how do we write this then? Well, 12.04 can also be written in a fractional notation. How will it be then? Okay, let's see. We have 12.04. Now, notice that this 0 is under a tenth. Okay, we can have it here. The first number is under a tenth. The second number is under 100. And so how many numbers do we have? 2 numbers. And so this will then give us, with reference to the last number, we will be having to divide our expression by 100. Why is that so? Because there are 2 numbers after the decimal point. And when we have 2 numbers, the second number is always under 100. And so, since that is what we have to divide the quantities with 100. And so what should this give us? Now notice that we have 12.04. It is not just 0.04. And so we have to include 12, then also 04. This is how we write 12.04 in a fractional notation. Now notice that you can still reduce this. You divide this by a number which can also divide 10. You divide 87 by a number which can divide 100. You divide 7 by a number which can divide 100, and also 1204 by a number which can also divide 100. So this is how we write fractions from decimal form to fractions in common fractions or common notation. Well, how about if we want to take the reversed route? How do we deal with that? That means we now have to move to question 3. Okay, question 3 is the exact opposite of what we did in question 4. So really quick and in a fast way, question 3 requires us to write common fractions to what? To decimal fractions. So we say common fractions to what? To decimal fractions. And so we move to what? We move to 3.1. So then what do we have for 3.1? Well, for 3.1, we have 1 divided by 2. Okay, we have 1 divided by 2. So how do we write this common fraction to decimal fraction? Now, what we want to do is first to express this fraction we have been given, which is what? Which is 1 divided by 2. We first want to express this fraction, 1 divided by 2, with a base of 10. How do we get 10 from 2? We get 10 from 2 when we multiply it by 5. And so we also have to do the same for the numerator. Why have we done this? It's because we want to express this fraction with the denominator being an exponent of 10 or a factor of 10. Well, what would this give us then? This would give us a 5 divided by a 10. And what should the final answer be? Notice we have only 1 10. And so, since we have only 1 10, which is a 10, what would we have? There we go. This is our table. You see this? We have only 1 number and a 10, meaning we will be writing this as a 0.5. Yes, this will be a 0.5. Then now when we look for the next question, which is 3.2, notice, even if this one looks a little bit unfamiliar, you will soon notice through questions that we are going to do as exercises that they are not really that difficult. And so the second question, which is 3.2, is what? is a 3 divided by a 4. And so how do we write that? Well, this is a 3 divided by a 4. What we want to do is to express a 3 divided by a 4 with a 3 divided by a 4 with the denominator being a factor of 10. A denominator must either be 10 or 100 or what? 200, rather 1000. That is from 10 to 100 to 1000. So how do we get to that then? Well, we have to look for a number that we can use to multiply for so that we get either a 10 or 100. And so what is that number? That number is going to be a 25. And also we do the same for the numerator, that is, we multiply it by 25. Now notice that when we do that, our numerator will change automatically from 3 to 75. And our denominator will change from 4 to 100. So now, what do we have then? Well, we have 100 because we also have two numbers here, 1, 2. So we can write this number as 75, but there must be a decimal point in front of 7, and so we get 0.75. Now in the next question, we have a 4 divided by a 5. That is question 3.3. Well, question 3.3, which is a 4 divided by a 5, can also be simplified in a similar way. That is, can be calculated in a similar way. Now, we have a 4 divided by a 5. The question is, how do you write it as a fraction in decimal notation? All right. So from this 4 divided by 5, the first thing we want to do is we want to make 5 becomes 10, or at least 100. Now we can make 5 becomes 10 when we multiply it by 2. Then also we have to do the same for the numerator. And when we do that, what we get is going to be, for the numerator we will then have 8. For the denominator we will then have 10. And so you notice that there is only one number as 8. So we write it there, 8. But notice, because we have 1 0 here for the 10, we put a fraction or a decimal point there, then a 0. For question 3.2, we could not find a way of expressing 4 as a 10, because that would mean we have to multiply 4 by 2.5, which is already a fraction, and we want to avoid dealing with that. Then now, for question 3.4, how do we handle it then? Notice that question 3.4 is 7 divided by what? Is 7 divided by 5. And so let's have it. So we now have 7 divided by 5. Okay. Now 7 divided by 5 is now supposed to be what? It's supposed to be written in a decimal notation. How do we write 7 divided by 5 in a decimal notation? Well, in a decimal notation, we have to find a way of writing the denominator as 10. And we do that after multiplying the denominator by a 2. So when we multiply the denominator by a 2, we will also have to multiply the numerator by what? By a 2. And what should this give us? Well, this should give us a fraction with the numerator being what? 14. And the denominator being what? 10. Since we have only 1 0 here, that means there will only be one number after the decimal point. So that one number is going to be 4 in this case, after the decimal point. And all the other numbers will come before the decimal point. And that number in this case is 1. And so this forms the solution to question 3.4. Now, notice that for question 3.5, you will do the same, which is 7 divided by 2. And for question 3.6, you will do the same, which is 65 divided by 100. So you just have to simplify it. They have already done for you one step. You just have to simplify that. So please try that out. Try question 3.5 and question 3.6. And when you are done, please submit it